logistics tracker using NodeMCU and GPS. How GPS works. Let's understand that first. GPS is an acronym for Global Positioning System. It was first developed by the United States Navy in 1960 and later made public for all kinds of applications. GPS uses a method called as triangulation as shown in the picture which is presented to you. Three satellites simultaneously work to get the location, velocity of a GPS receiver. Today, 24 GPS satellites are there in the space constantly working to provide us with the GPS information. The data from these satellites are transmitted in NMEA format, which is the standard protocol for GPS information. In today's session, let us understand how this data can be acquired and processed to get your present location and how do we upload them to the cloud, making a logistics tracker. Every order we purchase on e-commerce sites like Amazon, Flipkart, etc. comes with a live package tracking feature. It will be updated manually at the distribution centers but is not a reliable process in the complex logistics operation. In this session, we will build a simple logistics tracker with u-blox GPS sensor, NodeMCU and Adafruit Cloud. Yes, it is really simple. We are getting you a pictorial representation and it helps you in understanding the total process. In the origin, in the transit, in the destination, we track the location and we get you everything real time. Interfacing GPS to NodeMCU. u-blox is a Swiss company that creates wireless semiconductors and modules for consumer, automotive and industrial markets. Neo 6M GPS is their GPS transceiver module which can be interfaced easily with any of the microcontrollers. You can make the connections with reference to the picture that we have presented which explains the connections. Their table is presented for your easier understanding and the NodeMCU's 3.3 volt pin should be connected to VCC of GPS, ground should be connected to ground, D7 of NodeMCU should be connected to TX, D8 should be connected to RX. The same has been presented in the picture as well, which represents the circuit diagram. Installing GPS libraries in Arduino IDE. The data from the GPS sensor comes in NMEA format, which has a lot of data apart from latitude and longitude data. But we need only lat and longitude to know the exact location. The NMEA data looks as shown in the image that is presented to you right in front and the $GPRMC line is needed for getting the location data. It is a tedious task really to parse all this data, hence we will be using tiny GPS++ library to directly parse this data and to get the location details. It's the smartest way to get this done. The .zip file of the library is provided in the resources or you can go ahead to the GitHub link that is presented in front of you for downloading the tiny GPS++ library. You can download it and you can follow the procedure as we are explaining you right now. Once downloaded, you can go to the sketch and include library and in that you have got add.zip library option as the pointer is showing you right now. And click on add.zip library option and choose the path where you have the downloaded library files available with you. Configuring feeds in the Adafruit Cloud. You need to create a new Adafruit feed for uploading the lat and long data. Create a feed named location in the Adafruit IO. This feed will be used to store all the data sent from NodeMCU. You can see the snapshots which are presented where we can create the feed taking these guidelines. Here we are creating a new feed by the name location and description is optional again. We are giving used for storing location data. So once the feed is all created, we are all set to go. Publishing GPS data. Once the connections are made, we need to code the NodeMCU to read the GPS data and to publish it to the Adafruit Cloud. We have used tiny GPS++ library for getting the location data from the NMEA data. ESP8266 Wi-Fi for connecting to the internet and Adafruit_MQTT_client libraries for publishing the data to the Adafruit Cloud. And the same has been presented in the code right in front of you. A variable GPS of tiny GPS plus class is created for parsing the NMEA data into the location data. GPS serial is used for communication between the GPS and the NodeMCU. The D7, D8 pins of NodeMCU are used as the RX and TX for receiving the GPS data. LAT underscore STR, LNG underscore STR, LOC underscore STR are used for storing the location data appropriately. And the same has been presented in the code right in front of you. A variable named ESP of Wi-Fi client class is created for helping in MQTT connection. Another variable named feed of Adafruit underscore MQTT underscore publish class is created for publishing the data to the Adafruit feeds. And the same has been represented in the pictorial representation with a pointer pointing to it appropriately. Serial of NodeMCU is set at the baud rate of 115200 and the GPS serial is set at the baud rate of 9600. The remaining code in the void setup is used for connecting to the Wi-Fi and then to MQTT. It is similar as we have learned in the past, and it's a very simple code and we request you to go through it. Char location is used for converting the location data into character array before uploading to the Adafruit cloud, and this is a mandatory step. When there is an incoming data in GPS serial, which is GPS serial dot available greater than 0, then the data is read and encoded to the tiny GPS plus class format. This is important and in fact to be followed meticulously. If the location in the GPS serial is valid, then it gets uploaded to the Adafruit cloud to the location feed, and the same has been represented in the code. You can see that here if GPS serial dot available has got a valid data, it gets into the further code and we get the lat, long and the location obtained in, and further process goes on. In this session, we have shown you building a logistics tracker and how to upload the data onto the cloud. Instead, we want you to try to build a web page and host it on NodeMCU and show the location data on the web page. This is a challenge and we hope you definitely do it. You can build the web page by using your knowledge of intermediate courses. Don't worry if you are having any trouble or challenge in the middle. We have provided the code for logistics tracker using web page in the resources itself, and the screenshot is presented to you to motivate you. This is already done and we want you to try it once by yourself. The summary. In this session, we have moved a little bit far and made an application to track packages real time throughout the transit. To make this application, we have utilized the GPS sensor to acquire the location and uploaded it to the Adafruit cloud to make the data accessible anywhere from the world. You can also use LoRa communication for this application, which makes it easier by eliminating the edge processing and cloud updation. Let's go ahead with the demo right now. We are going to visualize how exactly the NMEA data looks like. But before that, you must be having a couple of queries in your mind. The first question would be like how the GPS module or what exactly the GPS module returns when it is connected to satellite and when it is not connected to satellite. We have a workaround here and we are going to get you a clear understanding on this, and then we will go to the demo part for the logistics tracker. You can see that we have connected our GPS module to the TTL dongle with VCC to 5 volt and ground to ground, RX to TX and TX to RX, and then it's connected to the laptop. Now let's go ahead and open the TerraTem. Once the TerraTem is open, select the appropriate serial, click OK. Once it is done, you are all set to go. You can see that there is some data which is coming in front of you and it is called NMEA data, and no location information is available. You cannot spot any location information available here, and this is when it is not connected to the satellite. When it is connected to satellite, the data feed would be different and it will have the location information. Now it's not connected. We are going to get it connected right now. The connection will be understood with the red indication that you have got right now on the GPS. You can see that we have got the location data made available right in the result, and that's because the GPS is connected to the satellite. And this is how you get the location statistics and the data from the GPS. Let's understand how exactly the logistics tracker can be built. Now we have used a NodeMCU and it is connected to the GPS sensor. We have already explained you how exactly to use the GPS sensor, and the connection diagrams have been given to you in the theoretical explanation. Please make sure all the connections are appropriately given, and this is nothing but the antenna that you are seeing in front of you. Once the satellite is connected or the GPS is connected to the satellite, we get everything easy, and this feed is going to go to the Adafruit. And please make sure that the red LED indication is on to let you know that the U-Block's GPS sensor is connected to the satellite. Go to Google and type Adafruit IO. This is where we are going to upload our GPS data that we are receiving. I have already got an account created, so I am going to sign in. I am signing in with my username and the password. So once it is all done, it's all easy for us to go ahead. I am signing in right now, and the next step is simple. We need to create a feed. Yes, we'll have to go to feeds. View all will let you view the available feeds, and we are going to create a new feed. The feed name is location, and description can be given as per your wish. Here we are giving used for storing location data. Once it is done, it is created and the work is almost done. You've got the location feed available, and currently there is no feed in because we have not yet executed. Let's open the Adafruit IO key tab, and you can see that we have got the username and the IO key copied, and this has to be pasted appropriately in the code that we have written to get it connected appropriately to the cloud. And here I need to give my Wi-Fi username and the password. Once the username and the password is given, we are all set to compile the code and run it. We are going to do that right now, and the code has to be saved. We have done the saving right now, and please make sure you have selected the appropriate board and the appropriate COM port is enabled for the process to be complete. Now the compilation is all done and it's getting uploaded. You can see that. Now the most important point to remember right now is the GPS sensor will not give you correct output when you are keeping it in-house. So please remove the power source, the USB cable out of the laptop, and connect it to an external power source, that is your power bank. And when you take it outside, you can get the GPS feed right now, and the feed will be updated in the Adafruit cloud. Now this is because the closed space connections does not work with GPS, and you will not get data when you are working in the closed space. That's the reason we have removed the power source and given it a new power supply through our power bank. And when you take it outside and keep it away from the in-house setup, you will get the GPS coordinates, and that's what you are seeing in front of you. We have taken it out, and the red LED blinking is showing that it is connected to the satellite, and all the data updates are getting into the Adafruit feed. And that is it. The process is very simple, and remember the procedure that we have given you, and you can repeat the same at your place as well. This is very easy exercise, and it can be done to track the logistics or to track anything with ease. Now, what we are going to do is we are going to take one of these feeds and we are going to test it if the location is all right. I'm doing it from Hyderabad, from my home, and I'm going to see if we are getting the same location identified with the Google Maps. I'm going to copy paste the location coordinates from the Adafruit, and I'm going to the Google Maps right now, and I'm pasting it in the Google Maps to identify the location. Now you can see that it's exactly the address that I'm sitting at, and I am making this video. That is it. You can track anything that you want with this kind of setup, and the NodeMCU being connected to it with ease, and the data has gone to the cloud for you to get it tracked from anywhere in the world.